you now know how to draw a box and whisker plot, and that can help us to visualize the distribution of data. And what that means is how the data falls around the median, and we'll see that we'll also bring in the mean in this lesson. We talk about distribution in terms of skewness. So what do we mean by skewness? Well, skewness, like if a picture on the wall is skew, then that means it's unbalanced or it's not straight. And the same is true for data. So skewness is a measure of the imbalance in the data. And we measure the skewness by measuring the relationship between the mean and the median. To understand different types of distributions and whether data is skewed, we first have to remember this word outliers. What is an outlier? We learned about it last year in grade 9. An outlier is an extreme value, it could be really high or really low, that doesn't fit in with the rest of the data. Some of you might have even read this book, Really Good by Malcolm Gladwell, where he talks about people who did unusual things and became successful. So it's sort of the same idea. Anyway, if we look at this example, here's a data set where I think it's quite obvious to see what the outlier is. 100 is the data value that's extreme. It doesn't fit in with the rest of the values, which are all less than or equal to 6. If we were to take the mean of this data set, or the average, we would find that the mean, now this is rounded, but the mean here is 17. But let's look at this. The average value being 17, well, that doesn't really fit in with most of the data values, because most of the data values range between 2 and 6. So this value of 100 is causing the mean to be much higher than it really should be. So it's skewing the data. This high data value of 100 is causing the data to be a bit skewed because it's pulling the mean upwards from the other values. Here's another example. Here are marks on a test. Now this one is fictional. Marks on a test, and these are in ascending order, so I can hopefully see quite obviously which one doesn't belong. The 10 is the outlier. It's the extreme value. In this case, it's a very low value that doesn't fit in with the rest because the rest are between 67 and 73. They're grouped quite closely. If we take the average here, or the mean, we see that the mean is 61, which is quite a bit lower than most of the values. So we can see that this very low value is causing a skewness in the data. It's pulling the mean downwards. So outliers can have a very interesting effect on a data set, and we need to be aware of that. So again, if we look back at this example where we're comparing marks for term 1 for 2 grade 10 classes at a school that is fictional, totally made up, definitely didn't use real marks. Let's just break this down and look at individual classes again. Here's 10.2's data by itself. And we're going to look at this to see if there's what the distribution like and if there's any skewness in this data. So first, let's remember what the box and whisker shows us. The minimum, quartile 1, quartile 2, which is the median, quartile 3, and the maximum. There's a key value that's missing from this diagram, and it's just not part of a box and whisker plot. So if you're like this guy, hopefully you've already had this thought, but what about the mean? We often talk about averages, and we often compare things based on averages, like on your mark sheets or on your reports, you get an indication of what the grade average was. So isn't the average really important? Well, yes, it is. So let's use the average to compare to our box and whisker plot. The average for this class was 63,3. So the average lies around about here. So let's look at this. That means that the average value, the mean value, is less than the median, which means that the mean value lies in the bottom 50% of the data. So what this means is that there's some value towards the bottom, or maybe a few values, that are pulling down or causing a skew in this data. If it were unskewed, the mean and the median should line up more or less equally. So, when the mean is less than the median, we say that the data is negatively skewed, because there are some values that are pulling the mean downwards from the rest of the data. Again, the majority of the data is going to be above this mean value. Now let's look at the data for 10.1. Firstly, the median was at 75, which remember means that half the data is below 75 and half the marks were above 75. The mean for this class was 75, was also 75, which means that the mean lines up exactly with the median. So what this means is half of the data is below the average and half the data is above. So there are no particularly extreme values that are causing the mean to be very high or very low. We say that this data distribution is symmetrical. So we've looked at two types of distributions already. We know that when the mean is less than the median, the data are negatively skewed. When the mean is equal to the median, like in our 10.1 example, the data is symmetrical. And if the mean is greater than the median, we say that the data is positively skewed. And what this means is that there's some high value, some outlier or extreme value that's pulling the mean higher than the median, or meaning that the average lies in this top 50% of the data. There's more examples, there's more explanation of this, I should say, on page 235 in your book. For homework, you have page 235 to 237, exercise 5, A, B, C, and D, F, and J. In all of those, you draw box and whisker plots. And I've given you quite a lot of practice at this because in an exam, there are a lot of easy marks to gain here, but if you don't know how to do it, you could lose easy marks. You don't want that to happen. So practice well on these ones. Letter F, if you're caught up on your work up to now, letter F should be simple because you've already used this data in exercise 2 and exercise 3. Same thing with J. If you're caught up with your work, J should be a breeze. And then K is a comparison one where you're asked some questions about comparing two data sets. Those of you in 10.2 who are trying to get into 10.1, as well as anybody who just wants some extra practice, do the extension which is in L. See you next time.